You mentioned that's not the only thing you do. So let's talk about the second big theory for this conversation, which is the multiverse, a term that you dislike because it implies that there's something beyond the universe. You prefer using the term bubbles or regions. But for the first question, just to introduce the topic, I'm going to use a colloquial term. What is the multiverse?
Yeah, so it's a great question. People use that term in different ways, actually. So we should also delve into that just a little bit. So I think the simplest kind of multiverse is just to say there's an observable universe.
Mm-hmm.
And what does that mean? It means that we look out with the most powerful telescopes we have, the most powerful instruments we have, and there's only a certain limited distance that we can see out to. The reason for that is fundamentally because the universe had a big bang, and it has therefore a finite age, 14 billion years. Light travels at a certain speed. So 14 billion years times the speed of light gives you the distance that you can see. Now, that's not quite right because the universe was expanding. You have to worry about general relativity and geometry of space-time and so on, but it gives you a sense. There's a limit to how far you can see. And so beyond that distance, we don't actually know what's out there. And anything we say about it is just inherently speculative, and it relies on assumptions about theories. So whatever's beyond the edge of the observable universe, maybe it's nothing, maybe it's more of the same, maybe it's something totally different. That is a kind of multiverse, right? We live in a bubble, if you want, a region that's bounded by a horizon beyond which we can't see. And whatever's beyond is unknown. Well, that's kind of the simplest, least controversial version of the idea of a multiverse. It's a bit like saying you live on an island in the middle of a huge ocean, you climb to the highest point, and there's a limit to how far you can see. You can see 30 miles, 20 miles, whatever, depending on how high the highest point is. You don't know what's beyond. There might be other islands, might have other people on them. There might be just more ocean. There might be the edge of the earth with all the water falling off. Who knows? So that's the simplest version of it. And when you ask, the current theories that we have, the theories that seem to fit data the best and the most coherent theoretically and so on, what do they predict? They seem to predict something really interesting. If you were to go far enough beyond the observable universe, that you would discover this very rich structure of other bubbles, other regions, some of which would look completely different from what's around us, others of which would be very similar. So that's the idea of this kind of bubble verse or a huge universe that's
different in what way? Sorry.
Well, if string theory is correct, so we mentioned earlier that string theory has these 6 extra dimensions.
Yeah.
And those dimensions have to be curled up. They have to be compactified in the region that we're in. Otherwise, we would have noticed them.
Yeah.
But we also said gravity makes geometry dynamical, it makes the geometry of space-time dynamical. It makes it change with time, and it can change with position. So one thing that can happen is as you move around, you may discover that those extra dimensions are no longer curled up so tightly or hardly at all. So there might be a different number of dimensions, or even some of the 3 dimensions that we see here could get curled up, and there'd be fewer dimensions. So that's really different. And that's pretty hard to visualize. Yeah. But imagine a cylinder, like a pipe, and you live just on the surface of that pipe. So you can walk left or right along it, or you can circle around it. But if circling around it is a sufficiently small distance, then for reasons we said before, you wouldn't even know that direction is there. You would live in this one-dimensional world.
Right. Yeah.
Now suppose you go a long distance down this pipe and it gets bigger and bigger and bigger. So now all of a sudden it has a very large radius. And now anyone will notice that you can walk around it. So that's an example of how you can go from effectively a one-dimensional world to a two-dimensional one. And that is the sort of thing that could happen in these other regions. Now, of course, if you actually went down there, you would not be able to exist anymore, because not just the human biology, but the fundamental particles you're made of don't even really exist in the same way in these other regions. They don't make sense in different numbers of dimensions. They're not truly fundamental, if string theory is right. And so not only could you not live, but it's not a question of needing a spacesuit or something. The fundamental stuff that you're made of wouldn't even exist. So there's no way to actually go there and experience that, unfortunately. It would be kind of fun to be able to take a walk in some extra dimensions, but that's not going to happen. But one thing I've worked on in the past is, are there signals? Could we do observations that would lead us to believe that this really is correct, that there really are these regions? So anyway, so that's a version of the multiverse. The last version has to do with quantum mechanics. And this is more the one that's been popular recently in movies and so on. And that's the idea that there are multiple possibilities, which in some sense are real. And one way of thinking about quantum mechanics is when you make a measurement, you get a certain result. The result seems to be random, and it's randomly selected from a set of possibilities. So you could imagine, for example, flipping a coin. Classically, just flip a regular coin, you get heads or tails. And of course, you get one or the other, and then you forget about the other possibility because it's not relevant to you. But if you wanted to, you could say, well, imagine the world is sort of split into two, and there's a version of me that sees heads and a version of me that sees tails. And they're never going to interact with each other. They don't really exist in the same space, but you could keep them both. And then maybe they flip the coin again, and now there's 4 versions of you, and so on. And you follow a certain path through this tree. The rest of the tree is there if you really want to think about it as a set of possibilities. So one interpretation of quantum mechanics is that those possibilities could interact with the one you're in. And they don't generally, or at least the effect they have is so small that we don't notice it. But for microscopic experiments, for example, if you flip a coin for a particle, you could send light through a mirror, which is half silvered. So the light can either reflect or transmit. And it has about a 50% chance of doing either one. We send a bright beam of light through, it'll split into these 2 paths. Send a single photon through, it'll follow both paths in some sense. So both of those possibilities will be represented in the particle's wave function, and they will then interfere later.
This is the many worlds theory.
This is the many worlds interpretation.